Trig students, I need to go over section 4.9, one example that wouldn't be a non-calculator question. You'd have to use a calculator for this. So I wanted to go over this example with you. It's a Ferris wheel, and the dot represents the person as they're traveling around. The distance d is the height above the ground, and obviously you can see from the picture that the height to the middle of the wheel is 25 feet. Now, that does not mean that the radius of the wheel is 25 feet. If the height to the middle is 25 and the height all the way to the top is 45, that must mean that the distance from here to here, which is the radius, is 20 feet. Now, I want you to think through this situation with me. I'll read through it, but we're trying to compare the circle to the wave and try to understand how it all goes together. It says, in the Ferris wheel pictured at the left, Darlene is in a seat labeled by point D. At the start of the ride starts at time 0. You don't start when you're at the bottom. You wait till everybody's been loaded into the Ferris wheel. You might start here. You might start here. You might start over here. You might start at the bottom, but that's not guaranteed. But the ride definitely starts at time 0. So like, for instance, the time 0, right, that would be the time when the clock starts, and that would be the time the ride starts. Okay, hopefully that makes a whole lot of sense. Time 0 is when the ride starts. Please remember that. Anyway, in this case it says it takes 10 seconds for Darlene to reach the top of the wheel. So obviously she didn't start at the top of the wheel, otherwise she'd already been there. But it takes 10 seconds for her to get to the top of the wheel, where she will be 45 feet above the ground, which is already indicated in the picture. If the wheel turns at a uniform speed of 2 revolutions every minute. Well, now what's that telling me? 2 revolutions per minute. That means 1 revolution in 30 seconds. So, that sounds like the frequency. We know that the frequency has a reciprocal relationship with the period, so that must mean that the period is 30 seconds. It takes 30 seconds to go around the wheel one time. Alright? So now, it can be shown that this equation, right here, gives Darlene's height in feet above the ground as a function of the time, t, in seconds after the wheel starts to rotate. Assuming the ride will continue for at least 2 minutes, find all the times. So that's 120 seconds. That's the 2 minutes. At which Darlene is closest to the ground. Find all the times when she will be closest to the ground. Because obviously, inside of 2 minutes, she's going to be at the bottom a few different times. What if I were to put this equation into the fireproof form? So that would be d minus 25 over 20 equals cosine. Now, what are we going to do inside here? This is all over 1. And how am I going to get rid of that pi over 15? We talked about that in class. We would multiply by 15 over pi, the reciprocal. Now, I know that seems kind of weird to multiply by 15 over pi to the top and the bottom. But if we do that, it would cancel out that fraction and give me t minus 10 on the top, because those would cancel. But if I multiplied it also to the bottom, I would have 15 over pi on the bottom. And so we can think about coming up with A, B, H, and K. A, that's the multiplier on the horizontal. Well, that's kind of weird. It's 2 pi, or it's 15 over pi. And we know that we can use that to find the period of the function, because the original cosine has a period of 2 pi, and then if we multiply that by 15 over pi, oh look, the pi's cancel, leaving me 2 times 15, which is 30. Now, that makes a whole lot of sense with what we figured out a few minutes ago about the period of the function. Now, the value b here, 20, that's the amplitude of the wave. Well, the amplitude of the wave, how does that relate to the picture? Looks like the radius. So, the amplitude of the wave equals the radius of the circle. Huh, that's an interesting thought. H, that's 10. That has everything to do with how long it took for her to get to the top. And K, that is 25. That's the center of the wave, which also happens to be the height of the center of the wheel. So those two things match. So imagine this being the center of the wave. All right, that's y equals 25. That's your K value. The amplitude, right, that's your 20. All right, or, going down, that's 20. But that has everything. So how high off the ground are you at the bottom? If 20 plus 20, that's 40, but we know that the maximum height is 45, right, because it said so in the diagram of the picture of the Ferris wheel. So that must mean that there's a distance between here and here of 5 feet. So when you're at the bottom, you're still 5 feet off the ground. That's good, so you don't scrape your feet. So, let's see here. Now, as you can see, they are using their graphing calculator. So let me grab my graphing calculator. You can grab yours. I know, it's that weird thing you don't know what to do with since you've been dealing so much in this chapter without it. So, first thing we want to do, since we're dealing in radians, is to make sure that our calculator is turned over to radian mode. Otherwise, it's not going to graph it correctly. Under y equals, make sure that there are no equations and no plots turned on. We don't want any of those plots up there turned on. So go up there and shut them off if you do have something. Since the graphing calculator is limited, I can't use the fireproof form. I must use the form that they gave it to me in. So 25 plus 20 cosine. And I'm going to use, let's see here, I'm going to use a couple sets of parentheses here. One for pi over 15. And then I'm also going to use another one for x minus 10. Okay, so see if you can get your equation to look like this. Now, the window that we're dealing with, let's take a look at the window that they made. I'll put it over here, see if that'll help. The window that they made looks like this. It went from -5 to 125 with an x scale of 10. And y scale -10 to 50 with a y scale of 10. So I should get a graph that looks like theirs. Now if I put y equals 25, that is the K value. That'll make a whole lot of sense when you see that drawn on the graph. So we've got our center line to the wave. HK sits right about there. It's 10 seconds and a height of 25. Excuse me, I'll have to stop the recording.